Where are we? We are right here. Going to share my screen. I'm quieter now than I was. Switch back there.
There we go. Maybe that'll help. Oops, you don't want my nail. You want the PowerPoint. There we go. Okay, so last time we talked about how to convert between units using that conversion chart. Sounds like a lot of you have had the chance to do the quiz. So that's great because that will be a primary way that you can practice this material. So I do highly recommend that you work through that quiz in the same week that we do it, or at least before the next class period, because that will really help you to keep up in class with what we're doing. We didn't quite finish the material from last time. So we can do this last problem and it'll serve as a little bit of a review for what we are going to do today in class, because it will naturally follow what we did last time. So we want to solve the following word problem involving conversions, and we want to round to 2 decimal places where necessary. So we're asking the question, what's the total weight in pounds of 3 cases of 425 gram cans of peas if each case has 48 cans? We are asked, first of all, to find the total weight. And we're asked for it specifically in pounds. We are given the number of cases and the number of grams. So that's another weight of each can of peas. So might be a good idea to start this one out by figuring out maybe what's the total weight that we have in grams. Looks like we have what? 3 cases of cans of peas. My little stick drawings here. There are 48 cans of peas in each case. So let's think about how many cans we have initially. The number of cans are, I could take 3 times 48, or I could take 48 plus 48 plus 48. And that gives me 144 total cans. That doesn't give me the weight of the peas, but it does give me a way to calculate the weight. So if I know the number of cans, then I can note that each of those cans has 144 grams in it. So I can find the weight in grams by multiplication now. I can take the number of cans, multiply it by the weight of each can, which is in grams. Bring back my calculator, can't do that one in my head. 144 cans times 425 grams per can. That gives me 61,200. 61,200 grams. Okay. So we have calculated the weight in grams of the peas. We don't want the weight in grams, though. We want it in pounds. So now comes in what we talked about last time. We want to figure out on our conversion chart, how do I convert grams to grams to pounds? let's see if I can make this work. There we go. Got a conversion chart going. Okay. So let's see, grams to kilograms. It looks like we could go from grams to ounces. We're gonna go to weight. So we can go, let's see, we can go from ounces to pounds, which is at the bottom here. Right here, ounces to pounds. So 16 ounces isn't equal to 1 pound. Can we go from ounces to grams? I believe that we can, because I wrote that down earlier as an option. Yep, right here, we could go from ounces to grams. So we can't go directly from pounds to grams, but we can go from grams to, grams to ounces and then ounces to pounds. That would be an option. Another option would be, we can see here that we have a pounds to kilograms. And we certainly do know how to go from grams to kilograms. So we could go from ounces to grams and then grams to kilograms, ounces to pounds, pounds to kilograms. Did I say that right? No, I didn't. We could go from grams to kilograms and then kilograms to pounds. And I think I'll do that latter one because that's what, that would kind of help us review two different ways to convert. So let's do that. 1 pound is equal to 0.4536 kilograms. Let's jump back to our problem. We can note what we just saw, that 1 pound is equal to 0.456 kilograms, 536, excuse me, 36 kilograms. Okay, great. So in order to convert from grams to pounds, I'm going to go from, first of all, from grams to kilograms, and then I'm going to go from kilograms to pounds. That is my process, my path. So I'm going to set up my 61,200 grams. And first of all, I'm going to convert it to kilograms. This is a metric conversion. So I'm going to write down my prefixes. King Henry died unusually drinking chocolate milk. Okay. And I can note here that we're starting with grams, which is our base unit, and we're going to kilograms. So I'm going to go 1, 2, 3 to the left, 3 decimal places. So 1, 2, 3 to the left. That gives me 61.2 kilograms. 61.2 kilograms. So we've gone from grams to kilograms. I'm going to write that as a fraction. I'm going to multiply it by my unit multiplier that has kilograms on top, or on bottom, excuse me, which means I have pounds on top. We've gone from grams to kilograms. We now need to go from kilograms to pounds. Those kilograms will cancel. We're going to use our unit multiplier here, or our unity fraction rather. 1 pound, 1 is the number that goes by pounds. 0.4536 is the number that goes by kilograms. The 0.456 is in the denominator, so I'm going to divide 61.2 by 0.456. Let's jump into our calculator. 61.2 divided by 0.4536 gives us 134 point, if we round to 2 decimal places, 134.92 should be the weight in pounds. And likes to jump to the top. All right. So that should be 134.92 pounds is the unit that remains. Okay, so that's a good review problem. A little bit of application, a little bit of conversion from between metric units, a little bit of conversion between non-metric units using that unity fraction. Any questions about that one? And is the audio still working? Okay, good to know audio is still working. And yeah, there are different ways to do this problem. You could have done it using two unity fractions. Okay, good to know. This is working out. Okay, great. So that finishes up lesson 3. Let's go ahead and jump into lesson 4, where again, a lot of this will look familiar. We're going to do area conversions. We're going to continue using, again, these unity fractions within the next several lessons. All throughout the rest of the test 1 stuff, we're going to use the unity fractions. Last time we talked about linear conversions. Today we're going to talk about area conversions. And again, you'll see it looks pretty familiar actually with one thing that we have to discuss as far as changing up our process slightly, but it will look a lot like the previous stuff that we've been doing. First of all, area. Let's define it. Area is the amount of two-dimensional space that a shape occupies. So by that, we can see the difference between area and what we've been doing in the linear case is now we're talking two-dimensional. And this applies to a variety of different shapes. There are a lot of different shapes that can be formed. Area measurements are used in a lot of applications, some of which I'm sure you're familiar with, such as painting. Paint is typically given in terms of the area that amount of paint will cover. Carpeting, physics application of calculating pressure. PSI stands for pounds per square inch, and square inch is a area unit. So calculate pressure using area. So it's an important concept to discuss with a lot of applications. We are mostly going to be focusing on a couple of different shapes. You can apply the basics of what we're talking about to a variety of shapes, but just so that we have a couple of familiar ones. Let's talk briefly about a rectangle and a circle. You can calculate the area of a rectangle by multiplying the length times the width of the rectangle. So if this is the length, this is the width, multiply those two dimensions together, and you get the area of that rectangle. Another that we will be using, another formula for area that we'll be using that is that of area of a circle. To find the area of a circle, you take pi. Pi is a specific number. We have Pi Day coming up. You're probably somewhat familiar with that. Pi is an irrational number. It's about 3.14159, et cetera, et cetera. A lot of applications will have you shorten pi, just as a warning here. A lot of applications will have you shorten pi to 3.14. But for the purposes of our class, I recommend that you look at your calculator. You probably have a pi button on your calculator. use the pi button on your calculator. And that's because 3.14 is a rounded version of pi. It's not exact. And so because we're multiplying in this formula, anytime we round, as we've talked about, that will amplify any rounding error for that. And so it's a good idea to get a little bit more exact for our purposes. So use that pi button in your calculator. Most calculators have one, including the one included on tests for Ujiverity. If you don't have that pi button on your calculator, then at least round out a few more decimal places than 2. So use at least the 5 decimal places that are listed here. And that should, in most cases, get you accurate enough. But there's that. Okay, so if we want to find the area of a circle, we're going to take pi, and then we're going to multiply that times the square of the radius. The radius of a circle is this distance from the center of the circle to any point on the outside of the circle. So as long as we know the radius of a circle, we can find the area of that circle. Okay. You don't need to memorize these formulas. If you need them, you will be given them on a test or quiz. So just focus on learning how to use them. And I'll point out the pi button on the calculator whenever we come to it as well. Let's do maybe a couple of simpler examples to begin. Again, here you're given the area formulas for a rectangle and a circle. Let's find the area of a rectangular room that measures 17.5 feet by 12 feet. Area of a rectangular room, we use this length times width formula to determine. And as long as we have the 2 dimensions of a room, we can use either one for length. So maybe let's just choose that first one, 17.5 feet for length. And then we multiply by the second dimension of 12 feet, choose that for width. Bring in our calculator, 17.5 times 12. 17.5 times 12 is equal to 210. No rounding necessary there. Oops, that's not what I want. There we go. 210. There we go. And then we want to be careful of the units that we use when we are stating the units of area. The units actually change. Note that we have 2 feet units that we're multiplying together. So our unit for area is square feet, which we can denote by feet with an exponent of 2 on there. So that's feet times feet. So just make that note that the units are not the same. We started out with a unit of feet for each dimension. We end up with a different unit, that of area. So area unit has the exponent on it, generally, the exponent of 2. Okay. Let's do the second one. A circular area rug. So we are given the fact that there is a circle involved, has a radius of 1.25 meters. We want to calculate the area of the rug. So for this one, since we're dealing with a circle, we're going to use that pi times r squared formula. We know what r, the radius is. It's 1.25. I will include my meters, and that is squared. So we can plug this into our calculator, but we have to be a little bit careful. Maybe in math 31, if you took that or other classes, you've heard of orders of operation. We're going to do the exponent first before we do this multiplication by pi. Orders of operation, or PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction, tells us before we do multiplication, the M, we do exponents, the E. So just make a note of that when you are working with formulas that involve exponents, because we generally want to do those before we do the multiplication. So let's do that in our calculator. Okay, so I'm going to take 1.25, square that. That is equal to 1.5625, and then I have a pi button on my calculator, which is down here on the bottom. I should not have done that. 1.25 squared. I'm going to multiply that by this pi button on bottom, and I get 4.9087, etc., etc. I'm going to round that to 2 decimal places, so it's 4.91. Don't know why this keeps moving to the top, but it does. So it's equal to 4.91. And again, our units are not meters. We're talking area now. We've squared those meters, so our units are square meters. Okay. Questions on those? Okay. And again, you don't need to memorize those formulas, but it is a good idea to do some practice with them just so that you know how to use them. Okay. Little bit of discussion on what area actually is. And then we can get to how we can do conversions in area. So area conversions can basically be done using the same methods that we have used to convert linear units. But we might notice here that, for example, we know this is true. We know that 1 foot is equal to 12 inches. Those are linear units. If we want to extend that to square units, then on the right, let's say we have a square that's 1 foot by 1 foot, which means it's 12 inches by 12 inches. If I want to figure out how many 1-inch squares will cover this 1 foot by 1 foot or 1 square foot area, this is a rectangle. So I can multiply 12 by 12, 12 inches by 12 inches, 12 times 12, and I get 144. So there are 144 small square inch little areas that will cover this bigger 1 foot square area. And we can think of that in general by saying that area conversion factors between 2 units are the linear conversion factors squared. So if I want to figure out what is equivalent to 1 square foot, I could take 12 squared, or 12 times 12. I know that 1 foot is equal to 12 feet. And I will get 144 square inches. So same types of factors that we've been working with before, only we square both sides of that linear conversion. And we can see that below. We know that 1 yard is equal to 3 feet. Therefore, if we square both of those units, 1 square yard is equal to 9 square feet, or 3 squared, 3 times 3, which is 9 square feet. we could do that in the metric system or between systems as well. We know that 1 inch is equal to 2.54 centimeters. So if we square both of those numbers, 1 square inch is equal to 2.54 times 2.54, which is 6.4516 square centimeters, etc. So same idea. You do have boxes for these in your conversion chart. We can talk about where they are. Let's see, units for area. Here are area conversions on your conversion chart, and that's for the customary system. You also have them for the metric system. I think that might be it. Yeah, I don't see any between systems for some reason. I thought there were, but maybe there are not. Let me go up a little bit. I see customary, I see capacity, volume. Yeah, I don't see any between, oh no, those are the between system. These are metric customary area conversions. There we go. Because we do the metric a little bit differently. I remember now. So there's the metric between metric and customary. So you have boxes for them on your conversion charts. Okay. Questions about this process so far? We haven't done any conversions yet. Okay. One thing you might notice is most of these units have that little square on it, indicating their area units. Not all of them do. For example, the acre. The acre doesn't have that exponent of 2 on it. It doesn't look like an area unit, but it is defined as an area unit. So we can see its equivalence here. A hectare or HA, that's a hectare, is something similar. It is a metric area unit. So there are a couple of these strange ones that you just kind of have to get used to. You wouldn't know by the exponent that they were area. Acre typically has to do with land. I'm assuming hectare does too, but I'm not a farmer, so I'm not 100% sure about that one. Maybe some of you all know me. Okay, let's see how we can set up these conversions. Like I said, unity fractions are what we are going to use. So we can do basically the same process as we did in the last class. Just refer to different boxes on the conversion chart. So if we want to express 1,750 square feet as square meters, then I'm actually going to jump up above. Let's find the conversion between square feet and square meters on this conversion chart. It is directly given here. So it looks like 1 square foot is equal to 0.0929 square meters. So I can take my 1,750 square feet. I can make it a fraction, so put it over 1. And I'm going to multiply by something for which the feet cancel. I'm going to put square feet in the denominator, so I have feet on top and feet on bottom. So the feet cancel, which means my square meters will be on top. And we said that 0.0929 square meters is equal to 1 square foot. So I'm going to put the 1 by the feet, 0.0929 by the meters, because the 0.0929 is in the numerator. I'm gonna multiply 1,750 times 0.0929. 1,750 times 0.0929 is equal to 162.575. Or if we want to round to 2 decimal places, 162.58. So 162.58 square meters. So again, we have to change our units, make sure that it is an area unit that we're coming up with. Okay, let's do this next one. We're going to express 5,500 square yards as acres. So we're going to begin by writing our starting unit as a fraction. And now we want to find a relationship between acres and yards, square acres and square yards, I should say. So let's jump back to our conversion charts up here. Let's see. Acres occurs here and here. Doesn't look like either of those will allow me to convert to yards directly. But what I could do is note that I could convert acres to feet. And then I could convert feet to yards. So I could go, let's see, what are we starting with? Yards. I could go from square yards to square feet as my intermediate unit, and then go from square feet to acres. I think that's a pretty good path. So I think that's what we'll use. Let's go back down. Let's see. I first of all want to go from square yards to square feet. And then we're going to go from square feet to acres. So I'm going to multiply by a unity fraction that has square yards in the denominator, which means it has to have square feet in the numerator. We have said that 9 square feet is equal to 1 square yard. That was the conversion factor we found. So I'm going to put 9 by yards, or 9 by feet, 1 by the yards. Okay. I'm going to wait to multiply because we're not quite done. We just converted square yards to square feet. I'm going to multiply by another unity fraction, converting feet to acres, or square feet to acres. This one has to have square feet on bottom because I already have a square foot on top. I'm now going to put my acres on top. So the square feet will cancel. And we can remember that the conversion factor we found said that 1 acre is equal to 43,560 square feet. It's a lot of square feet. So I'm going to put 1 on top for the acres, 43,560 feet. Let me make sure that was actually what we got. Yep, 43,560. Okay. Almost done. So we have, there we go. Hopefully you're not dizzy. We have set up our unity fractions. We can note that the 9 is on top, so I'm going to multiply 5,500 by that 9. The 43,560 is on bottom, so I have to divide by 43,560. I can do that all in my calculator at the same time. Let's pull it up. I can take 5,500 times 9 divided by 43,560. So that gives me 1.1363, etc. We're going to round to 2 decimal places. So I'm going to put 1.14 as my result in acres. So that is equal to 1.14, and acres is the area unit that I end up with. Questions on that? You feeling okay about this? It's not too bad. It's just a different place on the conversion chart. And you have to remember when you're converting that we're dealing with area units. So the conversion factors that we're used to, we have to modify slightly. Okay. Let's do an application then. Let's solve the following problem involving conversions, and we are going to again round 2 decimal places. We are told that there is this cylindrical column that has a radius of 25 centimeters. And we're asked to calculate the cross-sectional area in square feet of the cylindrical column. So this is an area problem. I like to draw a picture just to get an idea of what is happening here. So we have this column. It is cylindrical. So it's shaped like a circle with some height to it. We are told that the radius is 25 centimeters. We want to find this area of that cross section. So we're going back to our circle formula for this one. And we also want to note that we would like to find that area in square feet, but we're given the radius in square centimeters. So let's begin by finding the area in square feet. Oops, I need a pen. Let's find the area in, excuse me, not square feet, in square centimeters, because we're given the radius in square centimeters. So my area formula is pi times the radius squared, which is equal to pi. The radius is 25 centimeters squared. Again, I'm going to do that exponent first, and then I'm going to multiply the end result by pi. So let's bring up my calculator. 25 squared, oops, equal to 625 times, use my pi button below. So that's equal to 1,963.4-ish feet, excuse me, centimeters squared. I'm just going to leave this in my calculator for now. Not going to round yet because we're not quite done with this problem. So that's equal to about 1,963.495, etc. And we are talking area now. We just applied that area formula. So our units are squared now. It's not centimeters anymore, it's square centimeters. Okay. So we found the area. Let's convert that area to square feet. We're going to look back at our conversion factors that were given. And we're going to try to find a path from square feet to square centimeters. Square centimeters, it looks like it shows up here, not connected to feet. But I do have a way to go from centimeters to inches and then inches to feet. So I think that's the path I have to take. I'm gonna go from square centimeters using square inches as my intermediate unit and then ending with square feet. I think that's doable. Okay. So let's do that here. I'm going to take my 1,963.495, etc. square centimeters. Make that a fraction. I'm going to go from square centimeters to square inches first. So I want to multiply by a unity fraction that has the square centimeters on bottom, the square inches on top. That conversion factor we just found said that, let's see, what did it say? I wrote it down. Said that 1 square inch is equal to 6.4516 square centimeters. So I'm going to put the 1 by inches, 6.4516 by the centimeters. So it gets rid of centimeters. We'll do this again to get from square inches to square feet, which is where we want to end up. And we have said that 144 square inches is equal to 1 square foot. So I'm going to put, I need something with inches squared on bottom, feet squared on top, because we have inches on top here. I want those inches to cancel. My resulting unit, I want to be feet squared. So I can put 144 by the inches. I can put 1 by the foot. So we've set up our unity fractions. All I have left to do is, it looks like, divide by the 6.4516 and divide by the 144. Because both are in the denominator. That 1,963 is still in my calculator. So I'm going to use it. Divide by 6.4516. Divide by 144. Yes, you can do that all in a line like that. Which gives me 2.11 if we want to round to the nearest 2 decimal places. So 2.11 square feet, it looks like. It's equal to, pull out my black, 2.11 square feet. Can't really see it over there, can you?
I have a question.
Okay, what's your question?
So the first part of that problem you divided because it's one's on the denominator on that middle part.
Because the number that's not 1 is in the denominator.
Yeah, but why did you divide the last part? Oh, it's on the even though they're across from each other, they still divide. Because it's a denominator too.
Yeah, it's in the denominator too, exactly. Anytime the number that's not 1 is in the denominator, you're going to divide.
I get you. All right, thank you.
Other questions about this one? Okay. So well, let's see if this will work. I would like to zoom out. It's not letting me. So the more that we do these, we're kind of adding elements as we go. So this one got a little bit more detailed than perhaps some of the previous problems. But it is the same process over and over and over again. Okay. We can do one more application, I think. before we jump into the metric system. Let's do this. Solve the following problem involving conversions. Let's round to 2 decimal places where necessary, as usual. A farmer is planting seeds in a field with an area of 54.8 acres. A 100-pound bag, of seeds costs $8.95 and covers 25,000 square feet. We want to ask the question, how much will it cost to seed the entire field? So this is a practical application that deals with area, so acres and feet cubed. The area is given with a couple of different units, so we know we'll have to do a conversion of some sort. And then on top of that, we're asked to find a cost, which is not an area unit, but it is calculated using an area. So there's a lot going on in this problem. I think I'm going to highlight what I'm given here. So we have a field with an area of 54.8 acres. We have a 100-pound bag of seeds costs $8.95 and covers 25,000 feet. And we want to find the final cost to seed the entire field. So it'd be a good idea to have a plan before we jump into this. Just to get everything on the same page, let's start by converting our acres to feet, cubed. Squared, not cubed. Cubed is later. Just to get our units the same, because I'm given the cost in terms of square feet, and my final needs to be a cost. Therefore, that seems like the easiest first step for me to do. Once we have the amount of area in square feet, we can probably take that area and divide it by how many bags, essentially, that we will need to cover the field. So we're going to divide by number of bags, and those each cover 25,000 square feet. And that will give me how many bags that I will need to cover the entire field. And that will allow me to find the cost. So I think that's a good game plan. Let's start with the conversion. Let's go acres to feet. Or square feet, I should say. 54.8 acres. Let's turn that into a fraction. We want to go up to our conversions and figure out, how do I get from feet squared to acres? Luckily, we have a direct conversion between the two. 1 acre is equal to 43,560 square feet. So that's handy. 1 acre, 43,560 square feet. I'm going to multiply by unity fraction that has acres on bottom, which means the square feet go on top. So the acres will cancel. 1 goes with the acres. 43,560 goes with the square feet. So it looks like I'm going to multiply. 43,560 is on top. So let me take my 54.8 and let me multiply that by 43,560. And I get 2,387,088 square feet. So a very large number. 2,387,088 square feet. So that's step one, done. We converted from acres to square feet. Second, we want to figure out how many bags will we need. So we're going to take that 2,387,088. And we're going to divide that into 25,000 square foot pieces or square foot blocks and figure out how many of those are there. So take this, divide that by 25,000. And that gives me 95.483. And that'll tell me the number of bags that I need. Go back here. So that's 95.483, etc. One thing we want to note here is that tells me the number of bags needed. Number of bags of seed. I probably can't buy a part of a bag of seed. So we really need 96 bags. So we need 95 plus another part of a bag. So we need to buy that 96th bag. In case you're a farmer and ever want to sow seed in your field. Okay, so we have the number of bags. We now want to find the cost. If we need 96 bags, they each cost $8.95. So I can take my 96 bags, multiply that by $8.95. $96 times $8.95, that gives me $859.20, it appears. $859.20. So we've got a lot of parts to this one. The conversion was actually a pretty small part, but we used, we had to use kind of our mathematical thought process of what different operations were needed, what conversions are needed. How can I answer this question? We okay with that? I know I haven't stopped much to let you do things. I'm looking at the time and we're cutting it close again. That's okay. I'll probably give you a chance to do that soon. Yeah, rounding the number of bags isn't something that you would naturally think about. But in an application context, it does make sense. Okay. Good, good. Before we get any further, let's talk about the metric system and area. When we are converting between linear metric system units, we used that trick of counting the number of prefixes that we're moving. We can do the same thing with area. My lights, losing my lights again. Hold on. There they go. Okay. We can't do the same thing with area, but we have to examine our conversion factors again to think about how do we move the decimal point. We have said, for example, that 1 meter is equal to 10 decimeters. Those prefixes are right next to each other. Whenever the prefixes are right next to each other in linear conversions, then we want to move the decimal point once, or it changes by a factor of 10. However, just like in the customary system, let's say I have a 1 meter by 1 meter squared, or 10 decimeter by 10 decimeter square. If I want to find the area of that square, I'm going to multiply 10 decimeters by 10 decimeters, giving me 100 decimeters. So what that means in terms of our prefixes is if I want to compare two prefixes that are right next to each other in the metric system, if we are considering area, then there are actually 100 square decimeters in 1 square meter. So each of these consecutive prefixes differs by a factor of 100 instead of differing by a factor of 10. And what that means when it comes to converting between factors is that if I want to convert, say, from here 3.04 decameters to centimeters, then I can consider my prefixes again. King Henry died unusually drinking chocolate milk. And I can note that I'm starting with decameters and I'm going to centimeters. So I'm going 1, 2, 3 units to the right. But every time I do that, I am changing by a factor of 100 or 2 decimal places times 100 times 100 times 100. So each prefix that I move, I'm going to move 2 decimal places instead of 1. That's what it boils down to. To remember that, sometimes it's helpful to put little squares over the prefixes. If you know that you're converting between area units, if you put those little squares up there, then that will maybe help remind you to move 2 decimal places instead of 1. So here, 3.04, we're going to move 2 decimal places for each prefix. So I'm going to move 1, 2, 3, 4, 5, 6 decimal places to the right because I moved 3 units to the right. So we end up with this 3,040,000 square centimeters. Okay, so again, we can use those prefixes. It does work. We just have to remember that when we're dealing with area, each prefix change accounts for 2 decimal places instead of 1. Okay. All right. I will do one of these and then let you do a couple. Let's convert 162 millimeters squared or square millimeters to square centimeters. I'm going to write down my prefixes, but I'm going to put little squares by them to remind me I am starting with area. King Henry died unusually drinking chocolate milk. And then I can note that I'm starting with millimeters, square millimeters, I should say, which is right there on the left. And then I'm only moving 1 prefix to the left. But each prefix is worth 2 decimal places. So I'm going to go left 2 when I do this conversion. 162. Going to move 1, 2 to the left, giving me 1.62 square centimeters. So that should be my result. Each prefix accounts for 2 decimal places when I am working with area. Questions on that one? I could do this next one real quick, and then I'll let you do the last one, actually. King Henry, not that I doubt you, but for the sake of time, King Henry died unusually drinking chocolate milk. We're going to start with square centimeters and move to square meters. So C, square centimeters is there. I'm going to go to square meters, which is my base unit. So I'm going to go 1, 2 to the left. So I'm going to go left 2 and 2. So I'll go left 4 decimal places. So 1, 2, 3, 4. Therefore, my result will be 0.0314 square meters. So there is my my total in square meters. Okay, why don't you try number 3 and put your answers in the chat, please? Ooh, that was not a pen. Try that again. Why don't you try? Put your answers in the chat. We'll take a couple minutes on that. And make sure that you include units with your answer. Okay. Good. Yep. Yep. Okay, good. You are moving it to the right, as you should be. Great. Okay. Okay, I'll wait another minute or so. Okay, great. Okay. So we've got our prefixes, and I will go ahead and put squares up there. And I'm gonna note that I'm starting with kilometers, square kilometers. Great. Yep. Nice that you're putting the squares on your end result. That's what it should be. We're going to meters, square meters. So that is 1, 2, 3 units to the right, 3 prefixes to the right. So that's 2, 2, and 2. 2 plus 2 plus 2 is 6. So I'm going to move my decimal point 6 places to the right. So we're starting with 54.9, and I'm going to move 1, 2, 3, 4, 5, 6 places to the right. So I should have 5, 4, 9, and then 5 zeros after it. 1, 2, 3, 4, 5. So 54,900,000. And we do want to write the units as square units. So our final solution should be in square meters. Any questions on that?
Yeah, how do you do the squared part when you're putting an answer in?
And an answer, you can use a caret. See if I can type this.
I don't
Can
know
do
what
that. That little caret key is also the exponent on your calculator, in case you have a handheld calculator.
I'm talking like if we're typing it into our laptop when we're doing a quiz.
This little caret will work for that too.
I don't know what you mean by caret.
I just typed it in the chat. So there's a little arrow thing. I think it's on your 6 key on your keyboard. Yeah, the up sign. You can also say it that way. But that means exponent. Here, I'll write it down too. If you use this little key,
Yeah, I don't see it on my laptop though.
it should be on your number 6. The last M in this represents the prefix milli.
You have to hit a shift to do it.
Yes, you do have to hit a shift to do it.
Let me just try it just in the chat because I don't know if I'm.
Yeah, good thought.
Uh,
Try it in the chat, hit shift 6. You should see it.
Not doing anything.
Okay. Well, maybe after class, I'd have to see your keyboard.
Uh-huh.
But that should be on any keyboard. So maybe after class, we can look at it.
Yeah, that'd be great because I don't want to get something wrong because I'm not doing it right, but I don't see that on mine.
That's okay. I'd rather talk about that individually, where we can explore your individual keyboard and
Right.
then finish up what we got here, at least on one problem or two. Do we want to do this? Yes, let's do this. All right, let's introduce an idea. And yeah, if you got the M for meters and the M for milli mixed up, it is okay. That's why we do these problems in class. Let's talk about something called unit cost, which you have probably seen before, but it is applicable for this particular lesson. The cost per unit of material, so unit being 1 in this case. So the cost per 1 item or 1 square foot, for example, or 1 square yard would be the unit costs. And there's a lot of material like carpet that is sold by units of area, such as square foot, square yard, etc. If we want to calculate the unit cost of a material, then we generally will take the total cost of however much we're purchasing, and we divide that by the total area in the appropriate units. So as just a quick example here, if we want to calculate the unit cost in square feet of an 8 foot by 8 foot or 8 foot by 5 foot rug that costs $350, then we want to find the area of the rug first of all. This is a rectangular rug that is 8 foot by 5 foot. So area of a rectangle, 5 feet times 8 feet. That gives us 40 feet squared. So that is the area of this rug. To find the unit cost, I'm going to take the total area. No, excuse me, total cost. What am I saying? I'm going to take the total cost, $350, and I'm going to divide that by the total area, 40 feet cubed squared. Make sure I put my square in there. So I'll take $350, divide that by 40 square feet, and that gives us 8.75. So it looks like this rug costs $8.75 per square foot. Per square foot. So it's kind of an expensive rug. Okay. So that's an idea that we can use to determine, say, the total cost of carpet for carpeting a room, which maybe you'll need to do one of these days. Let's do an example with that. Let's solve the following problem. Carpet is installed in a room that is 8 meters wide and 12 meters long. We are given the cost of the carpet, the unit cost, in fact, at 75 cents per square decimeter. This is the unit cost. The cost of insulation is $75. We want to find the total cost of carpeting the room. So I'm going to do this fairly quickly because we have 1 minute, and then we can talk about it at the end if you want. Our room is 8 meters by 12 meters. So let's find the area of the room first. That's 8 meters by 12 meters. If you put that into your calculator, you're going to get 96, and it is in square meters. We are given cost in decimeters, not in meters. So let's go ahead and convert that to decimeters. King Henry died unusually drinking chocolate milk. We're going to put squares on them to remind us we're in area. We're starting with meters, which is the base unit, and we're going to decimeters. So we're going to go to 2 to the right. So that gives us 96,000 or 100 square decimeters as our area in decimeters. Okay. Using the unit cost, we can take the amount of square decimeters needed to cover the room times the unit cost, or the cost per square decimeter. Put that into our calculator. We get $7,200. To find the total cost, we have to consider the cost of the carpet, $7,200, plus the installation fee, which is $75. So that gives me a total cost of $72,075. Okay. That is it for today. We will, just like last time, probably do this last application at the beginning of class next time, just as a refresher, a reminder for what we are talking about. But I don't want to hold you any longer today. So you are free to go unless you have questions or want to stick around and talk about the little carrot key.
Professor,
Yes.
did you say 72,000?
7,200. Sorry, I misspoke.
Okay. Thank you.
You're welcome. You're welcome. And yes, I agree completely. Doing it yourself does really help. I try to do that when I can. Sometimes we're short on time, but I try to do that when I can. So have a good rest of your Tuesday. And I'll see you next class. Unless you're sticking around to ask questions.
Yeah, I was trying to figure out that carrot key because I'm looking all over my keyboard and I don't see it.
Great, good to hear. Rewatch the video. It should be up by tomorrow morning if you need to rewatch it. Let me show you what's on my keyboard. Let's see if I can find that. Let's see here. Let's stop sharing here. All right. This is not the best way to do this, but here's my keyboard. And it should be with my 6. You can see the little arrow on top of that.
Oh, I was looking at the numbers on the right of my keyboard on the
Yeah,
part of it. Okay.
yeah, look at the
so-
numbers above.
All right, so. Yeah, okay, that
Yep.
works. Yeah,
Great.
and that is what you use for the squared part.
That's what you use for any exponent. So and right now the exponent we're focusing
So-
on is the square.
How do you write that? So you're doing like, say, dm squared, you put dm caret
Yep.
and then a 2 after it.
Exactly.
Okay, that's a new one on me. You learn something new every day.
Yeah, it's not intuitive that that would mean exponent. So I'm glad that you asked about that. But on a handheld calculator, a lot of times that will be also the button for exponent. As you find that little caret key.
Yeah, it's just more like, looks like a mountain, but yeah. You
Yeah,
don't have to
up or
shift anything for that either. It's just the regular button. Cause I bought the calculator that you said to buy.
okay, awesome.
Yeah. All right. Gotcha. Thank you.
You're
And
welcome.
have a good evening.
You too. All right, anybody else have questions? Or are you just hanging out in the Zoom world? All right, I'm going to take that as you have no questions. So I'm going to end the Zoom call now.